Hello, Advanced Geometry. This is Mr. Donaldson, and it's the first day of distance learning, and I'll try to make it as easy on you as possible. I know it's going to be a little bit painful, but just bear with me. All right. So before we get into taking notes on what we're going to be studying in Chapter 11, similar polygons, I figured I'd just give you a quick rundown using the nerd program, Geometry Sketchpad, just kind of show you what we're dealing with. All right. So I constructed these triangles to be similar. You'll notice that when I move this big triangle around, the smaller one moves correspondingly. So essentially, as I make AB shorter, QR is getting shorter at the same rate. So what's happening here is these triangles are similar because they look exactly the same in every way aside from one thing, and that's their size. Right? So if I make angle A bigger, angle Q is getting a little bit bigger. And those triangles are always going to have that kind of same shape, just be a different size. All right. This part here is called a similarity statement, and it's really important because it tells me how those triangles are similar. It tells me which parts correspond. So I know that angle A corresponds to angle Q, and angle B corresponds to angle R, and angle C corresponds to angle S. I also know which sides correspond, just like with the congruency statement. That side AB corresponds with side QR, and side BC with side RS, and so forth and so on. Now, one thing you'll notice is when I show you the angle measures, which has been I have a typo here, sorry, I have an extra S. But when I show the angle measures for both these triangles, you'll notice in either triangle, the corresponding angles are exactly the same. They're congruent to one another. And right now, measure of angle BAC right here is 71.9 degrees, and so is the measure of angle RQS, which is this angle that corresponds to it. Now, when I change this triangle, because I made them so they're similar, all three of these angles are congruent to all three of these corresponding angles, and that's part of what makes triangles similar. There's another component that makes triangles similar, and that's about their side lengths. Now, of course, you can tell that the side lengths are not going to be the same. They're not congruent to one another, but let's take a look at those side lengths. So here they are. You notice they're all different from one another. So the angles were all congruent, and the side lengths, of course, they're all different if this triangle is substantially smaller than this one. But what is the same is if I take all of these side lengths and divide them by their corresponding side lengths, I'll get ratios that are all the same. And that's exactly what happened here. You'll notice that when I do AB divided by QR, I get 2. And AC divided by QS, I get 2. And BC divided by RS, I get 2. And that's because when I constructed these similar triangles, I made them so that the similarity ratio of triangle ABC to triangle QRS is 2 to 1. Every side length in this triangle is double the side lengths in this. And if I move this guy around, that ratio holds true. So, similar polygons. They look the same aside from their size. Same shape, different size. All right? The other thing that's important to know is that all the angles will always be congruent, and all the sides will be proportional. Proportional means in the same ratio. All right. Now, go over and let's take some notes on this.